Okay, so we're looking at solving systems of linear equations by elimination. So it's called the elimination method, or sometimes the addition or adding method. Both of them are fitting because what we're going to do is literally add our equations together in a way that would make one of the variables be eliminated. So I'm going to jump right into an example and we can see what I'm talking about. So let's say that I have 2x minus 8y equals 7 and negative 2x plus 5y equals 5. So here is definitely a system of linear equations, and we're going to use the elimination method. Like I said, that means that we're going to add them together. So this system is actually set up for elimination. If you notice, when I add these two equations together, first off, my x's are lined up, my y's are lined up, equal sign, and constant. So however your equations are arranged, they do need to be arranged in the same way, so you're essentially combining like terms. So when I add these together, combining like terms, 2x plus negative 2x is going to cancel out, right? Because 2 plus negative 2 is 0, so these do cancel out. Negative 8y plus positive 5y gives me negative 3y, and 7 plus 5 gives me 12. So we added them together, and my x's in this case were eliminated. Well, that makes solving for y pretty easy now. If I divide both sides by negative 3, I get that y is equal to negative 4. Now that I know what y is, I can take it and just plug it back into either one of my equations. It doesn't matter, I'll get the same answer, but I can plug it in and solve for the other variable, which in this case ends up being x. So I'm just going to take the top equation and substitute negative 4 in for y. So I'm going to plug in negative 4 for y. So we have 2x minus 8y equals 7, but I'm going to use the fact that y is negative 4 to find x. So 2x minus 8 times negative 4 is equal to 7. So 2x plus 32 equals 7. Subtract 32 from both sides, I get 2x equals negative 25. And divide both sides by 2, I get x is equal to negative 25 over 2, which is negative 12.5. So if you remember when we talked about solving systems by graphing, or if you recall solving systems by graphing, when we solve a system of linear equations, what we're essentially looking for is where those two lines cross each other. So it's common to write the solution as a coordinate if it's not an application problem. So we have x equals negative 12.5 and y is equal to negative 4, or negative 12.5 comma negative 4, either one of those. Alright, so there is the elimination method. And again, this one was already set up for elimination because if we added the two equations together, my x's automatically canceled out. But what happens if it's not set up for the method? How can we force it to have something cancel out? So let's say we have 4x minus 5y is equal to 9. And 3x minus 7y is equal to 10. And again, I want to use the elimination method. But if I just straight up add the equations now, 4x and 3x, that gives me 7x, negative 5y and negative 7y, that gives me negative 12y. So nothing cancels out. So what has to be true for a variable to cancel out? So let's go back to our previous example. Why did the 2x and the negative 2x cancel out? Well, the variables, the number was the same, but one was positive and the other was negative. That's kind of a requirement for things to cancel out. So I need the same variable, the variable to have the same coefficient, one positive, one negative. So it doesn't matter which I choose to force to be that way, but I need to decide, do I want to make my x's have the same coefficient, or do I want to make the y's have the same coefficient? I'm going to go ahead and pick the y's since the x's canceled out last time. And so looking at the y values, this is a 5 and this is a 7. You can decide what number you need to cancel it out, essentially the same way in finding a common denominator. If you had denominators of 5 and 7, the common denominator would be 35. So the value that we need here is 35. And again, one needs to be positive and one needs to be negative. They're both negative right now, so that means that I have to multiply one of the equations by a negative to turn it back into positive. So I'm going to take the top equation. Again, we've decided to cancel out the y's. We've also decided that the common value between them is going to be 35, which means I'm going to multiply the top equation by 7 and the bottom by 5. But I have to multiply one equation by a negative so that they have opposite signs. So I'm going to multiply the top equation by negative 7, and I'll multiply the bottom equation by positive 5. So the top equation becomes negative 28x plus 35y equals negative 7 times 9 is negative 63. And distributing 5 to all of the terms in the second equation, I get 15x minus 35y is equal to 50. Now we can see if I add these two equations together, my y's are going to cancel because I have the same coefficient, but one is positive and the other is negative. So I'll go ahead and add the equations together. Negative 28x plus 15x gives me negative 13x. 35y plus negative 35y cancels. Bring down my equal sign, and negative 63 plus 50 gives me negative 13. So now I just have an equation with x. So to get x all by itself, I'm going to divide both sides by negative 13. So x is equal to positive 1. We know that our solution is both an x and a y value, so I need to find the y value now. I do have pretty much 4 different equations that I could choose from. You can pick any one of the 4 equations to plug back into and you'll get the same exact value. So I'm going to take, I guess maybe the first equation and plug the x value back in and try to get the y value. So I'm going to take 4x minus 5y equals 9. And we're going to plug 1 in for x and solve for y to complete the solution. So I have 4 times 1 minus 5y is equal to 9. So 4 minus 5y equals 9. And my goal here is to solve for y, so I'll subtract 4 from both sides. 4 minus 4 cancels. So I'm left with negative 5y equals 9 minus 4, which is 5. Divide both sides by negative 5. And I get that y is equal to negative 1. So I found my x value, I found my y value. So our solution is either x equals 1 and y equals negative 1, or we could again write it as a coordinate. So I could write it as 1, negative 1. And there is solving systems of linear equations by elimination.